Hello. This was a viewer requested video, um, and I didn't want to mention their name in case they didn't want me to. Um, okay, so to start off, we have an x-axis. Oops. Sorry if I'm not drawing. I'm going to use the tool. Sorry if my drawing doesn't seem as straightforward and a little bit shaky today. Um, I was doing some intensive labor, and my arm's a bit shaky. Oops. What? Okay, there it goes. Okay, so if you think of like a Cartesian plane, you have an x-axis, you have a y-axis. If you think of it in terms of like math, if you remember anything about the Cartesian plane and everything when it came to like a math class, you had quadrants that were like positive, positive. And sorry, I always try to spare the math. Or like, you had well, I guess it would be like, well, yeah, I mean, it would be like x and y both are positive. You would have like a positive x and a negative y. You would have a negative x and a negative y, and you would have like a negative x. Am I doing this right? I guess it depends. I want to say a positive y. Did I do that right? Yeah. So, I mean, I guess this kind of depends. Okay, so you have a Cartesian plane with those things, and I just realized those are going to get in the way, so I'm going to quickly erase them. But just know that that's kind of like, I did not mean to do that. What layer was I drawing on? Well, I guess I'm just going to have to undo it. But you understand the point that I'm trying to say here, in which you have certain quadrants. It means certain things in different ways. But no one talks about the z or the z axis. And the z-axis is always a bit confusing because it recedes in 3D space. And in general, you don't usually cover this stuff until you get to like a calculus class, because dealing with depth dimension, it's probably extreme. It's very advanced. I mean, I would say even in like beginning calc, you just focus in on finding the area under like certain curves, but it does eventually get more advanced, and you may try to like figure out different formulas. So if I was to represent z, it's all around us. We have like a z here, a z here, a z here. It could be really anywhere. And the thing that's more important to understand about the z or z axis is that it recedes somewhere in 3D space. It could go in like, I mean, any dimension. If you just think of it as sitting behind, like z, z, I think z's the technical way, or it may just be another way to call it the z-axis. I don't know. I believe people in certain other countries will say z instead of z, but both are the same. Just know that. Okay, so we have a z-axis here. It could be here. It's pretty much like a back dimension in 3D space. So when you have a sphere, right? I'm going to try to do that a little bit more clean. I may have to try a couple times. No, that works. It could be cleaner. Oh, that works. Okay, so we have our sphere, right? This reminds me of another class that I had when I was like a freshman in a university, and it was just intro geology class, and it was talking about lines of latitude and lines of longitude, and basically, lat is fat. lattice fat. And the reason why I say that is just because that was the way I remembered it, because it seems kind of a bit weird to think of it. But know that like these lines that are like on the x-axis, in a sense, lat x-axis fat. Just a way to remember. You had lines of latitude, and we also have lines of longitude. And the lines of longitude could be thought of as going straight up and down. Like straight up and down. I don't mean to make it seem like I'm drawing partial ellipses on here, but I guess I kind of am. Oops. So we have lines of latitude and we have the lines of longitude. Or we have our y-axis. And the thing about that is, okay, we have our x and our y. No lines are really. How do you show lines to represent the z-axis? Well, the thing about that is, it's really up to you to do it. And I know that's not the thing people want to hear, but I'm going to show you. So we have our sphere, and I showed lines of latitude, and I showed lines of longitude. And when it comes to a sphere, if you draw things like partial ellipses that I just did here, that partial ellipse is receding into 3D space, into our z-axis. It's going around the thing. So you could effectively call it like how to show the depth on the sphere. So it can be helpful. You could either do partial ellipses or you could do full ones. But that's kind of like how you would represent it. There are various ways that you can do it, and kind of ways to show the curvature around the sphere that you want to do. I know it kind of seems a bit simple, but it's just an ellipse, and by adding either a partial ellipse to it, or you could have added a regular ellipse that you draw, like that would work as well. But the whole purpose of these ellipses that you draw that pretty much touches this corner and this corner, the purpose of that is to show the curvature around the sphere receding into 3D space. And it's as simple as that. So these are the tools at your disposal when you're drawing. You very well could do shading to do that. That's a little bit more advanced, and you probably are going to want to look at some type of reference, but I do want to tell you, if you are going to try to do that through shading, you want to have like a single light source, and you want to try to eliminate extraneous light sources, because it can kind of make it a bit confusing to deal with if you have light coming from many different angles, and if you don't have like some type of solid background to help you observe it in a more simple way. So we have our sphere. And the thing about that is, like, if you have other things, say an apple, I'm just drawing this apple from imagination, so please forgive me. Say you have an apple. It's going to follow that the same rule, in which you could use partial ellipses to show it. But the thing is, apples, you're probably going to want to use a variation of a partial ellipse. It's not so much as an ellipse you use on something like this, but like when you're showing the curvature, let's say it dips there, you have to show it kind of like that. So if you use these tools, like a partial ellipse that is a bit conforming to the 3D shape and 3D space, that can help you better understand the curvature around the thing. And I would say try to draw a lot of different types of spheres, or people may even call this an ellipse. I like to think of it as like, yeah, it's an ellipse. I mean, you could also think of like the Earth. I believe it's like it's an ellipsoid. It's not a perfect sphere. So, like what I did here, and I showed the lines of latitude and longitude, may be a bit misleading, because when an ellipsoid, like it's not an ellipse, it's an ellipsoid, the soid, so it kind of makes things weird. Like if you had a shape like an hourglass, let me try to do that. If you had like a gourd, and assume I did this perfectly, it's kind of hard to do. Let's say this is a gourd, right? It may go in certain areas, and it may, or let's say it's a light bulb, right? It does certain things differently compared to where it bulges out in certain areas. Because like you could think of the light bulb being like, well, you have your you have like the lower area that kind of like, if I could do that, which I can't. If you have like your lower area that has all of the threading on it to screw into a socket, then you have the actual light bulb part that kind of comes out. And I know this isn't the perfect example of a light bulb, but I think it works for the example. So I do recommend that you try to experiment with ellipsoids and different shapes, and like it can be a sphere, but it can be dealing with other types of objects like gourds, apples, pick any type of weird vegetable in your fridge or fruit. I'm sure you could learn something from it. I'm not saying you have to draw all the details of it. I'm saying just think of like the big picture shape and all of the individual things regarding it. Now, the last thing I want to say is, the whole purpose is the sphere. I drew a partial ellipse, kind of going like that way. You could draw it any way that you want to kind of show it. And the other thing is, it's interesting because like a sphere has no sides, like so. It's basically, I've always thought of a sphere as like an array of continuous ellipses. I mean, the other thing is maybe showing, like, I'm not really showing the best curvature, because when you're looking at it straight on, it may appear as a line, but I just kind of added that trimming to kind of show how it kind of goes like that. But if you were not hitting the corners right. But you can also use these ellipses to kind of show more depth of the ellipse that you're seeing, because here, if you could think of the ellipses to make up the sphere, kind of the further away you get, the more of that ellipse you're going to see. So you could draw, if I can hit the corners, larger partial ellipses, because you're kind of seeing more of that ellipse as the sphere turns in 3D space. So yeah, and then you have the end, and like I think the way I would always talk about it is like, if you think of like the very end of a sphere, there's a point, like there's something there, and I always thought of it as like the smallest ellipse that could exist. And I know this is weird because this is just me talking, but I've always thought of like the end of any point. I mean, I guess it could be literally any point on the sphere is literally just like a dot, but I look, it's a circle, right? So I always thought of that dot as also an ellipse, just a very tiny, minuscule ellipse that like you're not going to be able to draw as like an ellipse like that. You know what I mean? Maybe it's a perfect circle. Well, I don't know. Hard to say. But I hope this kind of helps give you some insight. And I know I may have gone on some tangents, but I do believe they were kind of important to kind of show the importance of it. I mean, it's really up to you to define how you want to use partial ellipses or regular ellipses to your advantage, the tools to show the depth of a sphere in 3D space. So yeah, I hope that video helps you. I always try to answer questions when I can. I hope my explanation was good. I woke up extremely early today and my body's a bit worn out, so I hope the quality was good. Thank you very much for listening. If you like my channel, please subscribe. If you like the video, please like it. And if you have a question, please ask in the comments. Thank you very much for listening. Bye.